In this video, we'll be learning how to find out the length of the unknown sides if the two shapes are similar to each other. So first of all, I'm going to start with the definition of the similar shapes. So the similar shapes are those which are the enlargement of each other. All the angles in the similar shapes are equals. The next thing is all sides must have the same scale factor. So how do we find out the scale factor is the length of the bigger shape, you divide it with the matching length of the smaller shape. So the key thing over here, you cannot divide by the any length, but you need to be dividing with the matching length. Okay, so the diagram shows that the one symmetrical panel in a tent, the sizes of the actual tent panel are shown on the diagram B. The sizes of the plan are shown in the diagram A. So what we are finding out is, we know that the two shapes are similar to each other and the work out the length of x and y. The first thing we always do in these sort of questions is to find out the scale factor. So to find out the scale factor is the length of the side which is given to us, the bigger one divided by the smaller one. So this is bigger one and this is the smaller one. So we know these two, but the only thing about that is we need to make sure they are in the same unit before we are finding out the scale factor. So we see that the bigger one is in the meter and the unit of the smaller one is a centimeter. So we know that the conversion from the meter to the centimeter would be multiplied by 100. So if we have been 4.8 meter given, to change that into the centimeter, it would be 480 centimeter because we multiply by 100. Now to find out the scale factor, rather we're using 4.8, now we are using 480 because the unit must be the same. Divide by this, which is 18. So when you divide them together, you'll come out with 80 divided by 3. Make sure you don't change that into the decimal because that would give you the recurring decimal. So if you're getting like the scale factor, it's a recurring decimal, then it's preferably you take it in a fraction form and do all your calculations using the fraction form. Now, another thing that we need to remember that is whenever we are finding out the length of the unknown sides, if we are going from the smaller one to the biggest one. So if we are going from the smaller shape to the bigger shape, we always multiply with the scale factor. If we are going other way around, which is from the bigger one to the smaller one, in this direction, that we're going to divide by the scale factor. So the first thing that's the reason we find out the scale factor. Now, once we know what the scale factor is, I'm finding out the length of x. So let's see what are the corresponding lengths. So this is the x centimeter, which I'm finding out, and what's given is 1.6 meter. To change 1.6 meter into the centimeter would be 160 centimeter. To find out the length of x, which is finding x over here, you're going from the bigger to the smaller. And remember, whenever we go from the bigger to the smaller, we divide by the scale factor. So we're going to do simply x equals to 160 divided by the scale factor, which is 80 divided by 3. Remember that whenever we take off the division sign to the multiplication, we flip the fraction. So changing them would be 3 over 80. And when you simplify it, this 0 will go with this one. How many 8 makes 16 would be 2, and 2 times 3 is a 6. So it means that the length of the x is going to be 6 centimeter. To find out how we're going to find out the part B, which is to find out the length of y, we know that we are going from the smaller to the bigger. So whenever we are going from the smaller to the bigger, we always multiply by the scale factor. So to find out y, I'm going to write down y would be 10.5. You multiply the scale factor into it, which is 80 divided by 3. And the simplification of that would give you 280 centimeter. Okay. Now from here, we know that the length of y is given in the meter, not in the centimeter. What we have found out is in the centimeter. So to go from the centimeter to the meter, you divide by 100 now. So you'll get 2.8 meter would be the length of y. So with the next example, we see that we have got the quadrilaterals, and the smaller quadrilateral has the side A, B, C, D, where the other quadrilateral, the bigger one, has got the sides E, F, G, H, where this says that they both are similar to each other. Because they are similar to each other, so it means that the length scale factor for all the sides would be the same. What we are finding out is the length of AD and the length of GH. The first thing that we're going to do is when the two shapes are similar to each other, we're going to find out the scale factor. But we need to see that we are using the right lengths. So see that now, if I compare the shapes, this is AB and the corresponding side to AB would be H and G. Now I'm going to do for the other one now. This is DC. The corresponding length on the other one would be is this one, which is ENF. Now to find out the scale factor now, what we're going to do is the bigger divide by the smaller. So that would be 22.5, but we always take the matching the side of the other one. So that would be 15 over here. So we divide them together. So when we're going to divide them together, we get this length scale factor, which would be 1.5. Now, to find out the unknown, we're going to see that what we are finding out is the length of AD. And where the length AD is basically x centimeters. So here AD represents 4. So the part A, we are finding out AD, which is basically finding out the x value. So to find out the x value, so the x value is here, this side. And the other x value would be on the other side, which is this one. Okay. Why we say that them two are similar? Because when we flip the shape, the bigger one or the smaller one, they would look exactly the same. And then you see that AD is corresponding to FG. So remember that when we are going from the smaller to the bigger, we times by the scale factor. And otherwise, from bigger to smaller, we will going to divide the scale factor. Here we see that to find out the length of the x, we are going from the bigger to the smaller. So we're going to divide by the scale factor. So we're going to write down 30 divided by the scale factor, which is 1.5. So you'll get, when you do 30 divided by 1.5, you'll get 20. So the length of x is 20 centimeter. To do the part B now, you're finding out GH. What GH represents is the y. So the corresponding of y is a 12. So them two are corresponding to each other. Because now we are going from the smaller to bigger, so we're going to multiply with the scale factor. So we're going to find out the length of the side y, we're going to do 12 times by the scale factor, which is 1.5. When you multiply them together, you'll get 18 centimeter, which is the length of y. And same as you can say that what y represents is, it's hg. So you say that hg and y is the same thing, and that would be 18 centimeter. Now we have got the next example now. So where this is that show that the triangle PQR and RST are similar. To show that the two triangles are similar, one of the cases we show that the angles within the triangle are the same. So we can show that all angles are same. If we are able to show that all angles are the same, then we say that the triangle PQR is similar to the triangle RST. I'm going to first of all start with this one. We see that this angle is the same by the vertically opposite angle. So I can rewrite this. I say that the angle PRQ is equal to the angle SRT. And the reason for that is the vertically opposite angles. Okay. Now, because we know that these two angles are the same, now we're going to use another one. So because this line is parallel to this one. And how do we know that they are parallel to this one? Because these are the arrow representing that the two lines are parallel to each other. Because the two lines are parallel to each other, by making that alternate angle, we know that or you can say that the Z angle. So this angle would be the same as this angle, because you see that it's making a letter Z shape. So whenever we have got a Z letter shape, which is kind of this thing, so we say that this angle is the same as this one, or it could be other way around like this. So we say that this angle would be the same as this one. So the reason for this would be the alternate angles are the same. For that reason, we say that the angle Q, P, and R is equals to the angle R, T, and S. And the reason for is the alternate angles. Or you can use the letter Z angles are same as well. Now, there are two ways of proving that the other two angles are the same as well, because it's making another Z angle. So you see that it's making another Z angle over by using this thing, then this thing, and this thing. So it's making the Z. It means that, again, this will prove that this angle 1, 2, and 3 are making it different from the others. So this would be same as this one. And the reason for that would be still the same, which is the alternate angles are always same. So to write down this one, I can write it down as the angle PQR is equals to the angle RST. And the reason is the same, that it's the alternate angles. Now clearly we see that all the three angles are the same. So therefore the triangle, or you can say that triangle PQR is similar to the triangle RST. So this is our part A, where we show that all the three angles are the same, and because all the three angles are the same, then both the triangles are similar to each other. Now what the next part is to find out the missing length, which is x, and to find out the missing length, what you're going to do is, you see that what are the two corresponding sides. So I'm going to show you that here. To find out the scale factor, the first thing we have to find out is the scale factor. Now the two corresponding sides are, because we see that this is the two angles here and this is the two lines, the green angle here. So we see that this angle and this angle is the same. The angle making at P and the angle making at T is the same. So this and this is similar to each other. So the corresponding side is the 8 centimeter and the 4 centimeter. You use them by finding out the scale factor. So the scale factor would be 2. To find out now the length of x, we know that because we are going from the smaller to bigger, so we're going to multiply. So to find out x, we simply say that 5 times 2 would be 10 centimeter, and that would be the missing side length. Here we have got the last example, and in this example they says that ABC is a triangle. Calculate the perimeter of the trapezium DBE and C. So I'm going to first of all highlight what we are finding out the perimeter of, which is DB, DB, and then DBC and E. So we are finding out this perimeter basically. So I've highlighted this part. So to find out the perimeter is basically to add all the sides. So we know that this length of the side is 7 centimeter. We're going to write it down over here. Now D to B is 7.5 centimeter. And the other ones we don't know. So we'll be finding out what BC length is and the length of CE. Okay. Now, what do we know about these? The big triangle ABC, that it's making another triangle. So it doesn't say in the question that the two triangles ADE and ABC are similar to each other, but we know that if the angles are the same of the triangle, then they both are similar to each other. I'm going to just quickly show you why I say that they are the similar triangles. So I say that the triangle ADE is similar to the triangle ABC. Now I'm going to quickly show why I say that both the triangles are the same, because the angle A is the common angle which you say in the triangle ADE and ABC. So of course, if I draw the smaller triangle and the bigger triangle, if I split the triangle, so this is my smaller triangle and this is the bigger triangle. The sides having the smaller triangle is ADE, the sides having the bigger triangle is A, B and C. Because this is a common angle, so this and this is the same. Now, because you're getting this length is coming from, so you see that this is a straight line. So we know that because this line is parallel to this one, which we see that through an arrows, then the corresponding angles are the same. So what are the corresponding angles are basically? So we say that the angle of this one would be the same as the angle of this one. So because we say that these are the two angles, so the angle making at B is same as the angle making at D. Same in the other side. If you look to the other side, you see that this is also making the corresponding angle. So this angle is the same as this angle. So we say that the angle making at E is the same as the angle making at C. Because all the three angles are the same, so we say that the triangle ABC is similar to the triangle ADE. Okay. Now, because we know that now the two triangles are similar to each other, it means that we can find out the scale factor. They go with the same scale factor. So before I find out the scale factor, I'm going to write down the length of the sides which are given to us. So the length of AD is 5 centimeter. The length of A to B is the sum of 5 and 7.5 would be 12.5 centimeter. The length of D to E is 7 centimeter. I'm going to write it down over here. The length of A to E is 6 centimeter. Now to find out the perimeter, we know that we are finding out this length and this length. Okay. Now, as we know that the two shapes are similar to each other, the first thing we're going to do is to find out the scale factor. To find out the scale factor, we always take the two corresponding sides. So we know that AB, which is this one, is corresponding. So this is AB, which is corresponding to AD. So we're going to divide them together. We always do the bigger divide by the smaller, which is 5 over here. And you get the scale factor from here would be 2.5. Now, to find out the length of BC, which we'll be needing over here, we do BC equals to, you see that the corresponding length is a DE. So you're going from the smaller to the bigger. So you multiply by the scale factor, which is 2.5. So simply you do 7 times by 2.5, and that would be, you get 17.5 from here. So this length over here, BC, would be 17.5. Once you would have the length of the BC, then you're finding out the next thing, which is to find out the length of this AC. To find out the length of the side of AC, we know that the corresponding side of AC is AE. So we're going to do, because we are going from the smaller side to the bigger one, we're going to do AE, which is 6 centimeter times by 2.5, and you multiply them together, would give you 15 centimeter here. Because this 15 centimeter represents the total length from A to C, and we are only be needing to find out this trapezium, the highlighted thing, we'll be only needing this part. So what we're going to do is we take away them together. So to find out the length of EC, we clearly see that it's just this part. So we're going to do 15 centimeter, which we found is the total length, you minus 6 centimeter from it, and that would be 9 centimeter. So to find out the perimeter now, we have got all the measurements, and we just have to add all the sides together to find out the total perimeter of the trapezium. So now we're going to do 7 plus 7.5 plus what we find out the length of BC is 17.5. So this we found out is 17.5, which is here. The other thing is we find out the length of E to C, which is 9 centimeter. So when you add all of them together, you'll get the sum of 41 centimeter, and that would be the perimeter of the trapezium. So here we have done all the examples on finding out the unknown lengths, and actually we tried some tricky questions as well. So it's all the type of the different questions we try to do over here, so to build up a very good and a clear understanding for you all. Hope you understand the topic from this video, and don't forget to subscribe to get updated with more videos then. Thank you very much.